We are developing nanotechnology-enabled treatments to treat this disease. We're leveraging a patented metamaterial platform technology invented at the University of Pennsylvania, and our core technology platform has been de-risked in our first program called VisiPlate, which is a minimally invasive glaucoma surgery. This is currently in its FDA IDE-approved clinical trial. Now, this has enabled us to develop a strong foundation for expanding our technology pipeline with VisiPlate-S, a suprachoroidal space device to treat mild to moderate glaucoma at the time of cataract surgery, V1, which is a sustained drug delivery effort, and a few other items that we're excited to share with you today. We have a world-class team and a renowned scientific advisory board, and we're fortunate to have closed $10.7 million in our recent Series A, bringing us to over $21 million raised to date. Our pipeline spans the entire spectrum of disease. Starting with mild to moderate glaucoma, we have our VisiPlate-S device targeting cataract surgeons. And our next milestone is to achieve preclinical de-risking in a first-in-human clinical trial. Our next program for treating moderate to severe primary open-angle glaucoma, targeting glaucoma surgeons, is further along in our FDA-approved IDE study, the SAPPHIRE trial. And finally, we have our sustained drug delivery effort, which has been funded by the National Science Foundation. So let's talk a little bit about the technology. At a high level, what we're working with is the world's thinnest freestanding material. If you think of thin films like Saran wrap, you might be able to use it to wrap your food and pick it up, but it will crinkle and crumple and fall under its own weight. Now, the materials we're working with are many times thinner than Saran wrap, but completely freestanding. They're flexible, they're robust, and they're highly biocompatible, and we manufacture them using highly precise MEMS technologies, similar to how you would make semiconductor chips for your phone. And this allows for a highly scalable process as well. So let's talk about glaucoma. Glaucoma is the world's leading cause of irreversible blindness, affecting over 100 million people around the world. And normally, our eyes are cycling and producing a fluid called aqueous humor. But in eyes with glaucoma, the drainage system becomes blocked, and that fluid builds up, leading to high pressure that damages the optic nerve. And reducing this intraocular pressure, or IOP, is the only way to prevent progression of disease. VisiPlate has a patient-centric design for longevity, comfort, and patient aesthetics. We avoid the main mechanisms of failure. First, we avoid occlusion with scar tissue by using non-scarring, non-fibrotic materials. Second, we have a multi-channel design to create outflow redundancy. And third, we have a surface area to maintain that space over time. The device is ultra-thin, many times thinner than a human hair. Maybe you can see it balanced on this fingertip, or maybe you can't. And it's that patented technology that ensures handleability despite its scale. We place VisiPlate in the subconjunctival space that's between the clear membrane of tissue in your eye and the thick white layer. And the tip of our device sits between the iris and the cornea. The whole device is patterned with a series of finely tuned microchannels, enabling that pent-up aqueous to be slowly wicked into its drainage zone. And that surface area of the device keeps that drainage location open over time. From there, the aqueous gets slowly reabsorbed into surrounding tissue, thereby lowering pressure within the globe and protecting the optic nerve. That's our introduction of VisiPlate, and now I'll briefly introduce VisiPlate-S, our suprachoroidal space device to treat mild to moderate glaucoma at the time of cataract surgery. Now, this device brings along that same multi-channel, ultra-thin, non-fibrotic approach we see with VisiPlate into the suprachoroidal space. That's one space lower in the eye than where we're placing VisiPlate. And the idea is very similar. Let us wick aqueous out to a natural drainage zone in order to control that eye pressure when the eye is already undergoing another intervention. Thank you for spending some time with me today. It was a pleasure to be here with you, and I look forward to meeting you after the talk. Thank you.